Okay, so in this video we are going to run through some mole calculations, and the first example I've got here is actually really simple. I'm telling you that you're starting out with 100 grams of calcium carbonate. I'm telling you it breaks down to give you 80 grams of calcium oxide, and I want to know how much CO2 you make. There's something called the law of conservation of mass, and that states that the total mass on the reactant side, which is the left side of the arrow, must be equal to the total mass on the product side, which is the right hand side of the arrow. We can see here on the reactant side I've only got one thing, and the mass is 100 grams, and that means that on the product side, added together, this must also equal 100 grams. If we know that 80 grams has gone to calcium oxide, then all we need to do is 100 minus 80 equals 20, and that tells me that carbon dioxide is 20 grams. So if I add these two together, I get 100 grams, which is exactly the same as what I've got over here. So you'll spot that this is what they want you to do. If they give you an equation and they give you the mass of two different things and are asking you for the mass of a third, typically this is only worth 1 mark because all you're doing is just subtracting. The next type of the question looks similar, but it is actually different. So this time, same equation, I'm starting off with 50 grams of calcium carbonate, and I want to know how much calcium oxide I'm making. Now I know from my law of conservation of mass that these two products added together must give me 50, but I don't know what the split is. Is it 40-10? Is it 25-25? They haven't given me the mass of either of them, so I'm not going to be able to just subtract. I don't have anything to subtract like I did before. So in this case, you're going to have to use what we call a moles table, and you're going to have to use your G Mr. Moles formula triangle. This is the one formula that you need to learn, and that's your formula triangle. Okay, so what I do, you're given the information to work out the MR as well, so I've given you the MR here. What you're going to do is you're going to draw me a little table, and into that table, whatever they've given you information about, so calcium carbonate, they tell you the mass of 50 grams, that means calcium carbonate is important, and I write down the formula exactly the same way as it is in the equation that they've given me. Whatever they've asked me about is important. So they've asked me the mass of calcium oxide, so that goes into my table. They haven't given me info about CO2. They haven't asked me about CO2, so I ignore it. Okay, so I'm only ever going to put two things in my table: what they give me info about, what they ask me about. And then down the side of my table, I'm going to put G Mr. Moles, the three things from my formula triangle: G, Mr, and moles. Now the G of calcium carbonate is given to me in the question. It's 50 grams. The MR of calcium carbonate is also here. It's 100. The other number I'm given is the MR of calcium oxide, 56. That will go here under MR of calcium oxide. So that's all of the numbers from the question filled in. I'm now going to use my formula triangle to do the third line. So from my formula triangle, if I cover moles, I see G divided by Mr equals moles. So I've got 50 grams divided by 100. That gives me 0.5 moles. However, when I come over to the calcium oxide side, I can't do that. I don't have a number for mass, so I cannot work out moles. That means you need a final thing in your table. R stands for ratio, and I get the ratio from the big numbers in the balanced equation. So if I come up to my balanced equation, there's no number in front of calcium oxide, which means the ratio is 1. There's no number in front of calcium oxide, which means the ratio is 1. And if these two numbers are the same, 1 and 1, then the two numbers for moles have to also be the same. So I've got 0.5 here, and I've got 0.5 here. So these two numbers are the same, these two numbers have to be the same. And I'm getting these ones from the balanced equation. If there's nothing use it to balance, then you just write down a 1. Now I know the number of moles, and I know the number of the MR. I want to find mass, and if I've covered mass, I can see it's MR times moles. So I'm going to be doing 56 times 0.5, should maybe else use my head. I can. It's 28. The answer is 28. So it tells me that the mass of calcium oxide is 28 grams. Okay. Now we're just going to run to the exam questions, which I have set to you for homework, and they are all done in this format, even though they might look a little bit harder. So you're given an equation, and this time you are told that you've got 0.043 moles of copper sulfate. Okay, so I'm going to circle copper sulfate. They've given me info about that, so that's important. And then they ask you to calculate the minimum mass of zinc. So zinc, okay, would be this one. That one will be zinc sulfate, this one will be zinc. Okay, so these are the two that I care about. So when I'm drawing my table, I'm going to put zinc into my table, and I'm going to put copper sulfate in. I'm not going to put the other two because I'm not given info and I'm not asked about it. And it doesn't matter what order you put these two into your table. Okay, down the side I'm going to do my G Mr. moles. Okay. But if I look at the number they've given me, they actually haven't given me a G. They've given me moles. They've given me the moles of copper sulfate. So I don't even need to calculate moles. They've given me that straight away, 0.043. Okay? And what are they asking me for? They're asking me for the mass of zinc. So that's what they want to find out. Okay? Now to get from this side over to this side, I need to use my ratio. There's no number in front of copper sulfate, so the ratio is a 1. There's no number in front of zinc, so the ratio is a 1. These two numbers are the same, these two numbers have to be the same, and that tells me that the moles of zinc is 0.043. The MR of zinc they've given to me here is 65. And then to work out the mass, remember if your triangle is this, to work out mass, it's going to be Mr. times moles. So I'm going to be doing 65 multiplied by 0.043, and I get an answer of 2.795. Now it says here they want your answer to 1 decimal place. So you can write it into your table, 2.795, but then when I come over here to the answer line, I'm going to round that up to 2.8 grams. Okay, the next one, I know it's the same story because again they've given me a balanced equation and they've given me info about one thing and they're asking me about another. So that's when I'm going to draw my table. So what have they given me info about? 1.35 grams of magnesium, Mg by itself, that's magnesium. They want you to calculate the mass of magnesium oxide. They want me to calculate this one. So these two are the ones that are important. So magnesium and magnesium oxide go into my table, doesn't matter what order. Down the side, G Mr. moles, and I'm also going to need my ratio. So the G, 1.35 grams of magnesium, that goes in there. The Mr. for magnesium is 24. The Mr. for magnesium oxide, I need to work it out. So I've got 1 magnesium and 1 oxygen. Magnesium is 24, oxygen is 16. So the formula mass, if I add those two numbers together, is 40. So that's all of my numbers put in. Okay, I now need to find moles. Remember, you're using G Mr. moles. And to find moles, it's going to be G divided by Mr. So I'm going to go 1.35 divided by 24. And I get an answer of 0.05625. Now do not round it at this point, okay? Write it to 3-4 decimal places. I can't do that over here, but I can use my ratio. So in front of magnesium, I've got a big 2 this time. So the 2 goes in for my ratio. In front of magnesium oxide, I've also got a big 2. So my ratio is 2:2, but that can be simplified to 1:1. You don't have to simplify it, okay, because the rule is the same. Because these numbers are the same, these numbers have to be the same. So this number here is going to be exactly the same. And then I multiply that by 40, okay, because moles times MR is grams. I multiply that by 40 and I get an answer of 2.25. Write that on the answer line and then I just double check it doesn't specify decimal places, and it doesn't. Next one, this one looks harder because they have this weird dot in the middle, but it doesn't change how you do it. Okay, so again, they've given me an equation. They tell me the mass of water formed. So they've given me information about water, so I know water is important. And if I read through it, the mass of hydrated copper sulfate, that's what they want. Now you've got copper sulfate here twice. CuSO4 is copper sulfate, okay? But hydrated copper sulfate, if something's hydrated, it would have water attached to it. So this is the one that they're asking me about, the hydrated copper sulfate. And what I'm going to do is I'm just going to put these things straight into my table. CuSO4.5H2O. You copy it exactly, and then you put your H2O. So I haven't brought my big number with me, but I've taken the formula exactly as it is. I'm just copying. And then down the side, G, Mr, moles, and ratio. Now, the G they've given me is for water, the mass of water. So the 4.5 goes with the water. The MR, for water, I'm going to have to calculate. They've given me that hydrogen is 1 and oxygen is 16. So I've got 1 oxygen, but I've got 2 hydrogens. I add them all up, and I get the MR of water is 18. Now, I don't need to calculate the MR of this guy. They've given it to me without calculating it, 249.5. 249.5. So I plug that in straight away. I'm able to work out the moles of water, 4.5 divided by 18, and I get 0.25. But for my ratio, okay, if I go and look at the balanced equation, there's nothing in front of CuSO4, so I write a 1, but there's a big 5 in front of the H2O, so I write a 5. So this is the first time that we've had this. So in the ratio, this shows me that the number on the right is 5 times bigger than the number on the left. And that means I have to have that same relationship on the moles line. This number has to be 5 times bigger than this number. So to find this number, I'm going to have to divide by 5. I need to make this number 5 times smaller. So if I divide by 5, I get 0.05. So both of these numbers are 5 times smaller than the numbers on the right hand side. The relationship is the same. And now that I have moles, I multiply it by MR, 249.5 multiplied by MR, and I end up with an answer of 12.475. Now, am I asked for a certain number of decimal places? I'm not. So 12.475 is going to be correct. So all I'm doing every time, okay, if you come back to look at what I've done here, I do a division to find moles, then I use the ratio, then I multiply. 3 calculations. Over here, I did a division to find moles, then I used my ratio, then I multiplied. Divide, ratio, multiply. Divide, ratio, multiply. It's the same every single time. And to recognize that you're supposed to use a table, okay, you're looking for a balanced chemical equation in the question. They give you information about one thing in that equation, and they ask you for the information about something else. Okay, so an equation, info about one thing, they ask you about something else. You're going to do this table, and it's literally divide, ratio, multiply every single time. The next one here is slightly different, okay? It says calculate the number of moles in 45,000 grams of titanium chloride. So initially, you're just asked to find moles. We know that moles is G divided by MR, okay? You're going to have to work out your moles of titanium chloride, okay? So titanium chloride is this one here. So to work out moles, I need my MR. Titanium is 48. And I've got 4 chlorines, which is going to be 35.5 times 4. So I'll add that up, 35.5 times 4 plus 48. You get an answer of 190. And then my grams, I've got 45,000 grams. My MR is 190, so I do 45,000 divided by 190. And I get an answer of 236.8. And again, it doesn't ask me for a balanced equation. And the next bit is the bit that's different. Show that 500 moles of magnesium added is in excess. Okay, so they're asking me to look at titanium chloride and magnesium. And if I look at the ratio between titanium chloride and magnesium, I've got a 1:2 ratio. And that means if I had 1 mole of titanium chloride, I would need 2 moles of magnesium. But we've just calculated that we've got 236.84 moles of titanium chloride. So how many moles of magnesium do I need? You just multiply it by 2, okay? The number on the right hand side has to be twice as big. So if I multiply that by 2, I will see that I need 473.78 moles of magnesium. That's what I need. Now they want you to show that 500 moles of magnesium is in excess. Excess, just means too much. So we've shown by calculation, using our ratio, that this is the number of moles of magnesium that we need, 473. They've added 500. 500 is bigger than 473, therefore 500 is too much. So that calculation there is enough for the mark. The next two questions are percentage by mass. I did this for you in the Easter revision homework. So I want you to press pause and I want you to try and do question 5 and question 6 for yourself. Press play when you're ready to see the answers and I'll have the solutions done for you. Okay, so for percentage by mass, if we look at the formula POCl3, you're asked about the mass of chlorine. You've got 3 chlorines in the formula. So you need to get the formula mass of 3 chlorines and divide it by the formula mass of the entire thing, including chlorine. So chlorine is 35.5, so I did 35.5 times 3, because there are 3 chlorines. And then on the bottom line, there's 1 phosphorus, phosphorus is 31, there's 1 oxygen, oxygen is 16, and then there's 3 chlorines, so it's 35.5 times 3. So that should be on top and bottom. Then you multiply by 100 to get it as a percentage. It doesn't ask for a specific number of significant figures, so I just left mine to 2 decimal places, 69.38, but you could round that up to 69.4 if you wanted to. The next one down here is the same. This one they're asking you about magnesium. There's only 1 magnesium in magnesium carbonate. So I put the mass of magnesium on the top line, 24. And then on the bottom line, I put everything, including magnesium. So I've got 24 for magnesium, a 12 for carbon. I've got 3 oxygens, which is going to be 3 times 16, times that by 100, and I get 28.57. The rest of the questions are based on fuels. I'm going to let you do them yourself. But I will just do question 11 with you, which is the equations. I'm going to let you balance for yourself. This one here though, B, calcium hydroxide, okay? This is where you just drop and swap, okay? You've got a 2 plus, you've got a 1 minus. So if I write those 2 down again, the 1 that is next to the OH should be coming down here, and the 2 that next to the calcium comes down here. However, okay, I don't just want 2 hydrogens, I want 2 OHs, and that means I'm going to need to use a bracket. So I've got 1 calcium, I've got 2 OHs, that is calcium hydroxide. For the symbol equation, all right, remember you're going to look at each thing separately. So I'm going to write the formula of lithium. Lithium is an element, it is not diatomic, it's just Li. Next up I do water. You need to know the formula of water is H2O. Next up I get to lithium hydroxide. That is a compound. You won't find that in your periodic table, and it's an ionic compound because you've got a metal and a non-metal. And for ionic compounds you need to use your charges. So lithium is in group 1, it's got a +1 charge. Hydroxide is one of the ones you need to learn, and we've seen that it has a -1 charge. +1 -1, the charges cancel out, so the formula is LiOH. And last up I've got hydrogen. Hydrogen is just an element, and it is on our diatomic list, so it's H2. So that's the equation. That gets you 2 marks, and then you'll need to balance it. Balancing this one is a little bit tricky, but when you go through it, you'll see that you need a 2, a 2, and a 2. Okay, that gives me 2 lithiums on each side. I've got 4 hydrogens there, 4 hydrogens there, 2 oxygens and 2 oxygens. Okay, this is one of the equations you're likely to maybe be asked, because we looked at this reaction when we studied the alkali metals. All right, so make sure that you can balance that one. It comes up all the time, and just remember it goes 2, 2, 2.